Thank you so much for the invitation to the NeuroSymposium. I'm very happy to be here. As was mentioned, I work at the McGill Office for Science and Society, which is a quite a unique little group that we have at McGill University to essentially answer questions that the public has on matters of science and to demystify all of it and to separate sense from nonsense. And I was asked to begin my talk by sort of contextualizing the importance of science communication worldwide right now. And I will begin with the obvious, which is that according to the World Health Organization, we're in the middle of an infodemic. And what does that mean? It means that there's too much information. It also means that there is false and misleading information, and that can lead to confusion. It can lead to unnecessary risk taking, and eventually to mistrust of institutions. And this came about because of COVID, but of course, even before COVID, we were having difficulty with just the information ecosystem online regarding sort of health and scientific information. And and because we're so connected worldwide, this has an impact from country to country. And so, for example, junk science from one country will come and influence many others. This is Didier Raoult, who is a French researcher who's been one of the most vocal proponents of hydroxychloroquine as a treatment and preventative against COVID-19. There's no good evidence that it works. There are terrible papers that seem to show that it works, but it doesn't. And his ideas have traveled worldwide and have impacted people sort of all over the world. Now, the good part is that it also means that science communication from one country can also reach others. So during the pandemic, I was interviewed twice by the BBC in Brazil because they've been having some very particular problem about misinformation and pseudoscience regarding COVID in Brazil. And so the stuff that I was doing here in Montreal was also having an international, sort of impact. And if I look, for example, at the analytics of our office, of the people who go to our website and read our articles, the vast majority of people are not Canadians. They're actually Americans. And we also have a fairly decent number of readers in the United Kingdom, in India, in Australia, and in a lot of other countries. So all that to say that whatever you choose to do in science communication, it's not just limited to your local community. It really can spread all over the world. So what I want to present today are 10 lessons in science communication, things that I've learned over the years from doing this that I hope you will find interesting and important for you. I mean, some of you are already doing science communication. Others, you might think, oh, I'll never do this. But you might be surprised that a few years down the road, you might find yourself engaging in communicating science to the public. And speaking of that, my first lesson is that there are a lot of different paths that lead to science communication. So myself, I started at the bottom of this diagram in research. I then moved up to diagnostics and molecular diagnostics. I then worked in forensic biology. I then came back down to diagnostics, then came back down to research. And then finally, I ended up in science communication, which sort of reaches all of these aspects, and everything that I've done so far really influences the kind of science communication that I tackle. And so, I did not go to school to study science communication, get a degree in science communication. I ended up through this long, convoluted path doing science communication. And I'm not alone in that. And so what I do now is, as was said earlier, so I'm a science communicator with the McGill Office of Science and Society. And what we do is we mainly write articles to inform the public about science, to denounce bad science and also fake science or pseudoscience. And I end up doing a lot of media interviews as well. And I've done my fair share during the pandemic. But this path that I took that led me to science communication, it involved me doing 3 years as a PhD student and abandoning my PhD. And a few years ago, I asked a bunch of people on Twitter who were doing science communication, like, how did you end up in science communication? Did you also, go through, one road and decide nope, and came back and did something else? And indeed, there were lots of people who were saying, yeah, I dropped out of pharmacy school. I left academia for health reasons. I came back. Now I'm doing science communication. I dropped out of a PhD program. There are lots of different ways of ending up where it is that I am communicating science to the public. So if you think for some reason that this is not the path that I've taken, I'll never do science communication, You never know. You never know how you might end up doing this. And I think that communicating good science to the public is becoming more and more valued. And so it's to be expected that this is something that researchers will be asked to do more and more. An important lesson in science communication, I would say, is to define your audience. So a few years ago, I met a professor of science communication at UC Davis, Sarah Perot, who had some very interesting things to say about this concept of who is your audience when you're doing science communication. And I want to relate some of the things that she told me. She said that there's no such thing as the public. We often use that. I use it myself as a shorthand for your audience. It's, people who are not scientists, it's the public. But what she was pointing out is that there are insiders and there are outsiders to each research area. And somebody who is an insider in one area is an outsider in another. If somebody showed me a paper on quantum mechanics, even though I'm a scientist, I wouldn't know what to make of it because I did not study quantum mechanics. So just because I'm a scientist doesn't mean that I'm never part of the public. I am also part of this public, and so are you. So what Sarah Perot was telling me is that you really need to respect your audiences. And a lot of researchers and students also are asked to, for example, to communicate their research to a lay audience. And what she was saying is that, well, you do have to recognize that a lot of people are not interested in your specific area of research. And their lack of interest does not make them anti-science, doesn't make them scientifically illiterate or inadequate in any way. And so instead of trying to figure out how to convince everyone that they should care about your very, very niche specific area of research, your time and energy might be better spent on identifying people who already have a reason to be interested in the kind of work that you do. I will come back to that because there is a little asterisk to be added to that. But I think generally speaking, it's a good thing to keep in mind. And because we don't typically think of who our audience is when we start to do science communication, I think the most common mistake that I see from people who begin to do science communication is that they write as if they are addressing other undergrads in their program. When you go to university in a science program, you are taught to write in a certain way, in a very academic way. We're writing scientific papers, we're writing reports and presentations for our fellow students and for our professors. And that's a very specific type of writing. It's very academic. It has to be very detached and objective, and you're using expert language and terminology. But when you are addressing the public, in large quotation marks, that kind of language is not very accessible. And so it's something to keep in mind, to whom am I writing this? I mean, who is my audience? Will they understand what it is that I'm writing? And so a piece of advice that I always give is try not to lose touch with who your audience actually is. One of the ways in which, so I also co-host a podcast called The Body of Evidence with a medical doctor. And we talk about health and medicine on the show. And before the event, we used to have a segment on the show, which was a vox pop, which is what you're seeing on screen right now. It's this idea of doing a street interview. You grab a microphone, you go on the street and you talk to random people. And you ask them, what they know about this thing that you're about to discuss on the podcast. And these vox pops were very useful to us because, Chris and I come from academia. My co-host, Chris Labos, and I come from academia. And so there are things that we sometimes assume that people know, but that they don't actually know. And this really, this was a lesson that we learned sort of the hard way when we did an episode on chemotherapy. We had not recorded the episode yet, but we did the vox pop first. So I went with a comedian. So we were hiring comedians to do this. Went to a comedian to an open mic night at a comedy club. And before the open mic night started, the comedian spoke to the other stand-up comedians who were going to go up on stage. And he interviewed them about the topic of chemotherapy. So we're going to play a short clip from this vox pop. And it's again, when I was there, because I was recording the audio for the comedian, I was just sort of stunned to realize that I hadn't thought of something. And it's going to become clear when you hear the vox pop. So I can't, because of technical reasons, I can't play the audio directly, but I'm going to ask Alice if we can play the vox pop on chemotherapy. Alice, can you hear me? I'll just stop sharing my screen. There it is. So I'm not hearing any sound. I hope people are.
Were you able to hear Jonathan?
Alice is coming online.
Can you hear me?
Yes, I can hear you now.
Oh, perfect. Did you see the video?
I saw a video pass by, but I didn't hear any audio.
Oh, okay, let me try again.
Sure.
Also, it helps.
I could hear the audio, so I guess I was the only one who couldn't.
Yeah, so also it helps
If you
when
could,
you mute yourself, please.
Okay, I will go back to my slides. I hope you could hear it. I could not, but I'm told that you could. So basically, what came out of this is that people didn't know the difference between chemotherapy and radiation therapy. And so my co-host and I had never thought to define what chemotherapy was on the podcast. And so by hearing this, we thought, well, we do need to explain what chemotherapy is before we talk about, the history behind it and the evidence behind it. So it was quite interesting because there is this thing called the curse of knowledge, which is that when you know something, it's very hard to be aware of the fact that other people might not know this thing. And that's what this Vox Pop does for us. Again, before the pandemic, it allows us to get a brief window into what somebody who's not an expert on this topic knows, has heard, and it can influence the kind of science communication that we do. So always ask yourself, will my target audience understand this basic concept, or should I explain it? Now, the flip side of this is you also don't want to overwhelm your audience with stuff. Because if you throw too much stuff at the screen, it's just going to be a little overwhelming and people might just pull out and decide that this is just too much for them. So we're going to play another clip. This one is a video clip. It's from a fairly popular video from a couple of science communicators in Ontario. And I won't comment any further than that, other than I want you to watch this clip and keep in mind this idea of explaining things and not overwhelming your viewer with content. So let me just stop. So if you could just play that ASAP Science clip, that would be fantastic. I will wait a few seconds for people who might be finishing the clip. So, I am not judging this video, but I just wanted to put it out there and ask a question: is this clear? And maybe your answer is yes. And I'm being a little disingenuous because I'm showing the final screenshot from it, and they really built up to it. And it may be an age thing as well. Maybe the younger viewers find this perfectly fine. I think it's a lot to throw at the person at the same time, and it's said very quickly. Um, but it's just something to keep in mind when you're deciding how much information to dose out at your audience. And a concept that I really like to talk about is pseudo teaching, which is not something that was put on my radar by Derek Muller, who is the guy behind one of the biggest science YouTube channels, Veritasium, and he's Canadian as well. And when Derek did his PhD, he studied different types of science videos, science educational videos, and he was basically testing different types of videos to try and convey certain basic ideas in physics. And so there were videos where two people were chatting about a particular concept. There were videos where somebody was talking to the screen, for example. There were videos where he was talking to people on the street about this, and they were doing experiments, all kinds of stuff. And he wanted to know which ones of these types of videos was the best to convey these physics concepts that he wants people to learn more about. And because it was a research project, he could do something that you can't really do on YouTube, which is that there was a quiz afterwards. So people would watch the video and then they would have questions that they would need to answer. Some of these questions had to do with, how clear was the video? Did you understand what was being talked about? And then there were actual quiz questions of like, okay, so if this were to happen, what is the answer to this particular question? What did you learn about gravity? All that kind of stuff. And what he noticed is that in a lot of instances, there were videos that looked like good teaching. From his perspective, it was clear. The students who were watching the videos felt like they were learning when they were asked, did you like the video? Was it clear, concise, easy to understand? Yes, yes, yes. When they answered the test, they said that they were very confident that they got the right answer. But when Derek was actually looking at the quiz results, he found that most of them had not understood the things that he was trying to convey. And so it's called pseudo teaching. It's fake teaching. It feels like teaching, but it's not. So just because it feels like you're teaching and just because your audience thinks it's learning does not mean that anything constructive is actually happening. And this is something that it's very hard to do anything with that because there aren't quizzes at the end of a YouTube video. There's no quiz at the end of an article, and even if there were, most people would not take the time to fill it out. But it is something that I try and keep in mind when I do science communication. I come back to this idea fairly often to try and make sure that what I do is actually having an impact. And sometimes the only answer that you have is that you get some feedback from some of your readers or viewers or listeners, and they will convey if they like what you're doing, if they understood what you're doing. They might have further questions, but it's just something to keep in mind of, am I really teaching, or am I just going through the motions of teaching? All right, moving on to lesson number 3, make sure that they care. And this was mentioned earlier on, that not everybody will care about your particular topic of interest, and that's okay. But I would add this little asterisk, which is that if you want to write about a topic that you think will be of interest eventually to somebody, that you think is important for your audience to know about, but that doesn't look interesting on its surface, you can figure out ways to hook your audience. And of course, the easy one is clickbait, which, at its sort of most extremes, you're basically lying to your audience. And then when they finally click on the thing, that's not quite what they thought they were clicking on. I would not recommend that. But there are ways of making a topic look more interesting than it might if you were to describe it in a very kind of sober, academic, scientific way. A couple of years ago, I believe it was when Carey Mullis died. So I wanted to write about him. So Carey Mullis, for those who don't know, he shared the Nobel Prize in Chemistry in 1993 because he created this new technique called the PCR, which is polymerase chain reaction. It's a way of amplifying DNA. And it is, I mean, it revolutionized the world, really. I mean, it's the COVID-19 test, for example, the swab in the nose. What happens to that swab afterwards? It goes through this PCR in order to detect, bits and pieces of the coronavirus. And so I wanted to write about this because he's had a very weird life. And I could have called my article, a tribute to the life and work of Carey Mullis. But the problem with that is that if you don't know who Carey Mullis is, you're not going to click on it because it's, who is this person? So what I did instead is I call my article "The Man Who Photocopied DNA and Also Saw a Talking Fluorescent Raccoon." Now, he did not literally photocopy DNA, but it's a good analogy for how PCR works. You're making copies of a very specific part of the genome. And he did claim to have seen a talking fluorescent raccoon. And so hopefully by having a title like that, you see this as you're scrolling through on social media and you go, wait, what? And you're more likely to click on it and to read on and to learn something interesting. So again, there are ways of framing the topic that you want to discuss in such a way that it just looks, the interest of the thing is popping up at the surface. I think it's important to keep that in mind. Lesson number 4 is make sure that they remember, because I mean, right now, again, infodemic. You go online, you see all sorts of headlines flying past, you read an article, you move on to another article. There's just so much information out there that I know that I personally want to make sure, as much as I can, that the people who are consuming my content are remembering, the basic take-home message that I have. So one of the ways in which I'm doing this is that at the end of my articles, I now have a box called the take-home message, and it usually has 2 or 3 bullet points where I try to summarize the important summary of my article, which is sometimes 2,000 words. And so by the time you're done with it, I want to make sure that you really remember the important parts of it. And I try to write it in as simple an English as I can, which is a huge challenge. But that is one way where I hope that you're done with the article, boom, you read this box, and then you move on to the next thing, and hopefully you've just looked again at the important chunks from that particular piece. Another thing, so that works fine for a written piece, but on the podcast we can't quite do that. And so something that we decided to do from the beginning, because we have these like 30-minute discussions on a particular topic, we want to make sure that at the end of that discussion, our listeners remember the take-home message behind this particular topic. And so what we decided to do is to have a jingle. So we kind of summarize what the take-home message is in a way that is short, that is pithy, that might rhyme, and we work with some local singer-songwriter and musicians who put this to music and who record a jingle. And so at the end of this discussion, I will say the line, Chris will say the line, we will both say the line together, and then the jingle kicks in and you hear that line a few more times as put to music. And the idea is that hopefully, if the line is catchy enough, our listeners will remember that even as they go away from the podcast and go and do other things. Hopefully, that line will continue to sort of circle around in their brain. So this is the last bit of media that I'm going to show. So if we can go to, I'll stop sharing my slides. This was an episode on beauty products. So a lot of beauty products, they make a lot of health claims that are not substantiated, and so we were trying to answer the question of what is the best beauty product, what has the best evidence behind it, and we were discussing on the show. We made a brief mention to and his name is escaping me at the moment. But anyway, we asked our singer-songwriter Joseph Hackle to write it in the way in sort of in the way of David Bowie. There we go. So let's play that jingle from our episode on beauty products. So, even though I couldn't hear it right now, it's been sort of ingrained in my brain that I could actually hear it in my brain. It's sunscreen because sunscreen prevents photo aging, and it's quite powerful in that way. So there you go. So that's sort of a creative, outside of the box kind of idea of how to make your science more memorable. If you're using an audio medium, of course, you need to be able to sing and to play instruments, or to know people who can do this for you. So we've been very lucky to have people like Joseph Hackle and Jillian Correa to do this for us. All right, lesson number 5. This is probably what I hear the most in science communication. It's the piece of advice that is just sort of making the rounds all the time. Use storytelling, right? Tell stories. It's such a powerful tool. Try and harness the power of storytelling. I'll give a few examples. I'll start with an example from a book called "The Science of Celebrity" by Timothy Caulfield from the University of Alberta. Its first edition was actually called "Is Gwyneth Paltrow Wrong About Everything?" And it's a book about celebrity culture and sort of the intersection between celebrity culture and science and pseudoscience as well, and sort of the wellness space, because lots of claims just don't have good evidence behind them, but they're endorsed by celebrities. And so in his book, Timothy writes about very scientific stuff like levels of cortisol in the blood and vitamin D supplementation and cosmetic surgery and the body of evidence on fame. He cites a paper in Nature on overconfidence. And it's stuff that could be very kind of dry and academic, and people might not want to read about this. But this is how he opens his book. Damn, I shouldn't have slept so long, is my first thought when I see the size of the line, which is already the width of a boxcar and the length of an aircraft carrier. It is early in the morning and cold. Many of my line mates have blankets and a diminishing food supply. It is clear they have been here for a very long time. So what's happening is that he is in line to audition for American Idol. And so the way that Timothy frames his book is that he begins with a story, with a narrative of him trying to experience the thing that he's about to write on, and then he will cut away from that and do a deep dive on the literature on this particular thing, and then he'll go back to his story and then do another deep dive, and then back to the story. So it's story, evidence, story, evidence, story, evidence, and it makes for a really, really fun read, and it helps the medicine go down, as it were. um, my favorite book about alternative medicine is Trick or Treatment, by Etzon Owens and Simon Singh. And I'll give you an example of, again, a very kind of dry topic that they mention at some point, which is the thing that correlation does not necessarily equate to causation. So just because two things are happening at the same time, or that they're moving in the same kind of direction, it does not necessarily imply that one causes the other. This is a very foundational bit of knowledge from epidemiology, and it's often something that people forget about. And so they wanted to write about this. Now they could have done so in, like, again, in a very academic way, but here's how they frame this. We can see why a correlation should not be confused with causation if we look at a neat example invented by Bobby Henderson, author of The Gospel of the Flying Spaghetti Monster. He spotted a very interesting correlation between the increase in global temperature over the last 2 centuries and the decline in the number of pirates. If correlation is synonymous with cause and effect, then he speculated that the decline in pirates is causing global warming. Henderson therefore suggested that political leaders should encourage more pirates to take to the seas in an effort to combat global warming. Now, obviously, this is a very silly example, and that's why it's a good example, because it will stick inside of your mind. It's a very silly example. It's very vivid, and it's a good way of illustrating what is otherwise a very kind of dry mathematical concept. Now, of course, you might be telling me, hey, Jonathan, I'm not writing a book right now. I get it. Neither am I. So what if I don't have a whole book to play with and tell these long, stories? Well, you can still do so in shorter articles. So I'll give an example of the director of our office, Professor Joe Schwartz at McGill. He has a column in the Montreal Gazette called The Right Chemistry. And he wrote many years ago about the potential health benefits of drinking tea. And this is how he structured his article. I'm not going to read the whole thing, but essentially he begins by telling a story about him visiting Chinatown in San Francisco, like a true story, like this actually happened, of visiting Chinatown in San Francisco and being sort of pulled aside by the owner of a tea shop who is making all these bold claims about tea. Oh, you drink 8 cups a day. It's the best thing. You'll never get cancer because of the antioxidants. And the way that the article is structured is, once again, just like with Timothy Caulfield's book, you start with a story. Then he delves into the scientific data. Okay, so what do we know about the potential health benefits of drinking tea? And then he goes back to his story at the very end to tie things in a neat little bow. And so this is a good way of, once again, sort of hooking your reader instead of just going like, oh, here's the evidence behind the drinking tea. You start with a fun story, and then you delve into the evidence once you've got the attention of your reader. Maybe some of you are asking the question, why? Why should we use storytelling? Well, it's because we love to tell stories. I mean, we are a storytelling species. We've been telling stories since we've had language, since we've had illustrations, ways of drawing on cave walls. Stories is what our brain craves much more so than data or numbers or papers or studies, unfortunately, but that's how the brain is wired. So if you can tap into that, you're more likely to get the attention of your potential audience. Now, if you're writing about a discovery, about a paper, about something that was discovered and it's being reported in a paper, something that you can do instead of simply saying, well, this new paper shows X, Y, Z, and this is how they did it, you can turn your lead scientist into a protagonist and tell the story of the discovery. Now, I'm not saying that you should make stuff up. That's actually not what I'm saying. But if you're, for example, if you're interviewing the PI or the students who contributed to this discovery, and you ask them the right questions, you'll be able to see how they eventually arrived at this actual discovery, and you can tell that story, which will, again, will be more interesting than just dumping the information on the lap of your reader. And I'll give an example from a piece written by which prize, the Pulitzer Prize winning Ed Yong, who just won the Pulitzer Prize for his coverage of the pandemic for The Atlantic. This is a piece that he wrote a while back about a fungus that was using a virus to control an animal's mind. And again, he takes us through the research itself that happened. So he writes, most leads fizzled out. Eisen's team tried to see if the yeast the flies eat could influence their actions. Nope. They checked if the microbes in their guts had an effect. Nada. That, ironically, was why Elia started leaving plates of fruit out. She wanted to collect wild Drosophila to check if their gut microbes differed substantially from the lab-bred insects. But when she discovered the Entomophthora-riddled carcasses, it seemed that she had inadvertently found the puppeteer that Eisen had been searching for. So it kind of reads like a thriller, right? So you are now inside the lab with these people. There's a puzzle to solve. They're trying to figure out the answer to their question, and they just don't know. They try different things, they get different results, and that is really fun as a reader to be taken through this actual process. Speaking of storytelling, lesson number 6: figures of speech can help convey complex and sometimes invisible concepts. So again, when we're in university and we're taught to write in an academic fashion, we are told to stay away from figures of speech. Your writing should be clinical and very, very objective. But when you're writing for a lay audience, figures of speech are welcome, and they can be very, very useful because, again, your readership or your audience, more generally speaking, may not have a good mental representation of the things that you want to write about, things like DNA and RNA and what's happening inside the brain and neurons. So figures of speech can really help. And there are lots of different kinds of figures of speech. The most basic one, of course, being the analogy. This is like that. So it's a comparison between two things, typically to explain, to clarify. I was going to play an example, but this is absolutely not necessary. So we all know what an analogy is. It can be quite useful in the context of science communication. Metaphor takes it to the next level. This is that. Right? So it's a figure of speech that describes an object or an action in a way that isn't literally true, but it helps explain an idea or helps make a comparison. A few years ago, I was writing a piece about the influenza virus and the fact that we have this seemingly weird nomenclature of H number, N number. So why are certain types of influenza viruses called H3N5 or whatever. And so it's because H and N represent different proteins that the virus expresses. And so I wrote about the quote unquote life cycle of the flu virus. And this is how I did it. And I used a lot of metaphors. So I wrote at some point, a second viral protein enters stage left. Its name is neuraminidase, or NA for short. Neuraminidase is the virus's answer to its own Achilles heel. You see all these viral pups. Again, it's a metaphor. They're not actual puppies, but they are newly made viral particles. So you can think of them as pups. They're ready to burst out of the cell in which they were born. Again, not literally born. They're covered in hemagglutinin, and as soon as they would touch the outside of the cell, they will stick to it. A mighty viral invasion would thus be quickly curtailed by the very mechanism that facilitates influenza's entry into the immortality machine. Neuraminidase is a highly specific sickle, again, not literally a sickle, but it kind of functions as a sickle, that cuts sialic acid molecules from the surface of the human cell. As the viral pups make their way out, NA essentially removes the Velcro from the surrounding area, ensuring the newfangled viruses disperse upon emerging from their womb. Because again, if you haven't studied molecular biology or cellular biology or virology, and I'm trying to make you understand what is happening with these viruses infecting these cells and coming out of them, you're missing just so much material. But if I can use metaphors, I can give you these sort of pictures, these analogous pictures that will make it easier to understand what is going on at this sort of nanoscopic scale. Another way to go about this is to use anthropomorphism. So this is the attribution of human characteristics or behavior to a god, to an animal, to an object. So a fellow science communicator in Quebec was writing a piece and doing sort of a cartoon about clinical trials. How do you illustrate a clinical trial? It's not a thing, it's an abstract concept. And so what he did was that he used the paper, the article, reporting the results of a clinical trial, and he anthropomorphized that paper, gave it some eyes, some arms, some legs, and now you can illustrate this paper, this trial, in a lot of different situations, and it's kind of cute, and it helps you understand how scientists in this particular case can make a clinical trial say whatever they want if they have the ill intentions. And finally, humor. So being funny. Again, something that is sort of frowned upon in academic publishing, but when you're addressing the public, as long as you do it sort of within reason, you can use humor, and it just, again, it makes the medicine go down. Again, from Ed Yong about impregnating rhinos. Since rhinos are so large, ultrasound won't work through their bellies or flanks. You have to go in through the rectum, which means there is, quite literally, a lot of shit in the way. So there you go. So that earns you a Pulitzer Prize. So don't be afraid of using humor. All right. So lesson number 7. We do not live in an anti-science age. The reason why I bring this up is because I see a lot of these kinds of headlines. We're living in anti-science times. People just don't trust scientists anymore. They don't trust science. They're completely unreasonable. And of course, all of this is due to millennials, right? The millennials are always to blame for these things. It's the avocados and the toasts. That's what this is. So is this true? Let's look at some facts, right? And for that, I'll be citing from a very good textbook on science communications called The Science of Science Communication. And the thing is that if we talk about trust in scientists, right, it really fluctuates due to recent events. It will vary depending on the topics. And so what I like to say is that it is more accurate to say that some people reject some science for some reasons. And I'll give an example of that. So when was the last time that you encountered someone who doubted X-rays, or somebody who was just very skeptical of the science of X-rays? Like it rarely happens. So it's not that people are just anti-science, they just reject all of science. No, it's cherry picking. There are certain aspects of science, certain domains of science that they disagree with for some reason. And one of them might be genetically modified organisms or genetically modified food. And so surely we can collectively say that, as a whole, people are just anti-science when it comes to GMOs, right? But even there, it's not quite true. Again, quoting from this textbook, after 20 years of persistent agitating, anti-GM groups have not only failed to generate the level of public anxiety, right, that has historically surrounded issues like nuclear power. It's still a big one. Toxic waste disposal, air and water pollution in the United States. But they have failed to even produce discernible comprehension that GM foods exist at all. Less than half of the public realizes that genetically modified foods are already on supermarket shelves and about 3/4 of every food product on sale. And only a quarter, incredibly, believe that they have ever consumed any genetically modified food. So, when specifically asked, bewildered survey respondents say that they prefer the issue of whether and how to regulate GM foods simply be left to expert regulators to deal with as those experts see fit. Now, if like me, you are interested in pseudoscience and in propaganda and all that kind of and conspiracy theories, that might not jive with what you see online. You might see all this stuff that I'm showing right now, all this sort of anti-GMO sentiment and this propaganda and those syringes full of colored liquids that are injecting peppers or apples. But you have to remember that the internet really amplifies extreme voices. And that can give you a skewed perspective on an issue. And I'm not saying that, there is no anti-GMO sentiment. There is, and it is a problem, and it needs to be addressed. But it's not nearly as bad as it may look when we just, take a dive on the internet. So as I was saying, only some sciences generate controversy for some people, and the following tensions are usually at play. It's usually a question of efficiency versus equity. It might be a question of benefits versus risk, and we're seeing a lot of that with the COVID-19 vaccine discussions. It might be between regulation and freedom of choice, and we're seeing this with the public health measures against the pandemic. Science versus traditional values versus traditional ways of knowing versus religion. Political priorities versus environmental values. That's usually where you have these tensions that lead to certain people, certain sections of society saying, I disagree with scientists on this particular issue. Because broadly speaking, trust in science is quite high. I mean, every year 3M does their State of Science Index survey. And you can see, again, these are broad questions. And of course, we can argue if how representative or how meaningful these questions are. But when they ask a question, I am skeptical of science. Do you agree with this? Yes or no? As you can see in the last few years, this has gone up from 29% to 35%. And then after the pandemic hit, a few months after that, they redid the survey. And all of a sudden you had from 35 down to 28% of people saying, I'm skeptical of science. So not too bad, not too shabby. So there is this myth of public perception of science that this is what's happening, that like nobody trusts scientists anymore, or nobody trusts science anymore. It's horrible, it's terrible. But the reality is more like this. Yeah, there is this area over there that's problematic and it needs to be addressed. But overall, public does trust science and scientists. So that's reassuring. All right, lesson number 8. The information deficit model probably doesn't work for emotionally loaded topics. What do I mean by that? I'm going to give you 2 scenarios, and I want you to think about them, see what the difference might be between them. Scenario number 1. This is Mark. Mark is one of those few people that I mentioned earlier. He doubts the science of X-rays. He doesn't understand how X-rays work. He doesn't trust them. He disagrees with X-ray technologists, doesn't trust X-rays. He is missing information in his brain about X-ray science, about radiography, how this works. We write up this information, we give the information to Mark, and Mark suddenly becomes pro X-rays. He understands now how X-rays work, and now he's pro X-rays. Scenario number 2, Jessica doubts vaccine science. There's some information missing in her brain about the safety of vaccines, the stuff that we already know about this stuff. We write up this information, give it to Jessica. Jessica takes it and reads it and becomes pro-vaccination. This is a rhetorical question. I can't hear you, but is there a difference between these 2 scenarios? Is one scenario more likely than the other? And hopefully most of you know that scenario number 2 is more unlikely to happen. X-rays generally don't generate strong emotions in people, but vaccines really can. And the information deficit model, it's a model that guides science communication by indicating that the reason that the public disagrees with scientists is right. There's just missing information, consensus on this issue. Now that model of they're missing information, I'll just give them more information. It is true for certain topics, but it is not quite true for others. I mentioned vaccines. It can also apply to climate change. It can also apply to the food that we eat, although there is evidence to suggest that sometimes being anti-GMO is just because you just don't know enough about how genetic engineering works. Medicine is another topic that can be very emotional to people. The theory of evolution when it conflicts with religious beliefs, gender and sex. So there are these topics that are just very emotionally charged, and where people just giving people more information is not necessarily going to work, because these strong emotions, the topics that stir up these emotions, they are part of who we are, how we identify in society. On the left is Dan Kahan, on the right is Dwight Schrute from The Office. Don't mix them up. But Dan Kahan and his colleagues have contributed many studies to the literature on this particular problem that I'm talking about. And they define a thing called the cultural cognition theory, which states that when your identity is threatened, your brain will find ways to reject the new information in order to preserve its identity. Right. So if you're anti-vaccine and I come along and I give you more, I say, no, you're wrong about this, and here's why. The brain of the person who's really anti-vaccine may turn into a lawyer and try to preserve their identity and try to defend them at all costs. And if you're interested in this topic, I would invite you to listen to You Are Not So Smart. It's a podcast, episode 133. It talks also about tribalism, how we sometimes act like we're part of these little tribes. Because the thing about Jessica, who does not trust vaccines, is that she is not alone. She is typically surrounded by other people in her community who share her views about vaccines. And if she suddenly were to change her mind about the safety of vaccines, to suddenly say, oh, I'm pro-vaccine now, she would risk losing that community and finding herself all alone. And her brain does not want that. Now, you may say, okay, that's great to know, but like, if I want to write about these issues, what do I do? Should I not write about these things? No, you can write about these things. And there are ways around this kind of emotional identitarian trigger that I found quite helpful. The first one is to remind your reader that you share their values before talking about the science, right? So if we're talking about food, instead of being antagonistic and sort of sitting on the other side of a table and being perceived as an opponent, you can start by saying, hey, we want the same things from our food supply. We want it to be nutritious, right? We want it to be affordable, right? We want it to be safe to eat. Okay, so we agree on this. We agree on these values. Okay, now let's look at the evidence behind genetically engineered food. And this way, you've set the table in a way that you're both sitting on the same side of it. Right? You're both looking at the evidence together, having the same set of values. You're part of the same community, if you will. So it can help sort of diffuse any potential tension. Empathy, right? Using empathy. If you're writing about childhood vaccination, you may say, well, vaccines can seem scary as a new mother. I mean, we want to protect our babies from harm. When I had my first child, I remember that. Now, of course, don't make up a fictitious child if you don't have one. But if you do, if you are a parent, you can talk about your own experience of going through this. Maybe you were anxious about all of these childhood vaccines that your baby had to have. And you can share that with your audience so that it kind of humanizes you, and it makes you um, admit that, hey, I understand where you're coming from. I've been there myself. And this empathy can be very good to convince somebody that you're not this kind of shill that is paid by pharmaceutical companies. You understand the anxiety that they're feeling. You've shared it yourself, but you managed to get over it. And here's how. If you're debunking an explanation that is wrong, it's a bad explanation, you need to give your readers a better one if it exists. I've written a lot about homeopathy. Long story short, they're sugar pills. There's nothing in them. But some people who have the flu will go and they'll buy homeopathy and then they get better. And they think to themselves, well, here's what happened. So I was feeling sick. I bought some homeopathy. Homeopathy worked. And now I got better. And I come along and I say, no, homeopathy doesn't work. And they say, well, how do you explain that I got better? So I have to talk about regression to the mean, which is that when your symptoms are at their worst, they can only go back to their mean, their average value by definition. That illnesses are self-limiting, right? The flu doesn't typically last forever. Some people do die from the flu, but most people do recover. So at some point, your immune system kicks in. So you have to give them a better explanation for what they went through than the bad explanation that they had. And as a callback to lesson number 2 about knowing who your audience is, remember whom it is that you are trying to reach. And this may be the most important slide that I have. The people who are strongly against you, especially if you're writing about controversial topics, they can hardly be reached. I just don't bother because it's a waste of time. It's stressful. It doesn't go anywhere. The people in the middle, the people who are undecided, they're on the fence, they're confused, they've heard things from both sides of this issue. Those people are my audience. These are the people that I can talk to. I can bring information to them, and they're open-minded enough to change their mind. And the people who already agree with me, that's great. They can share what I've done with their own communities, right? So if I write an article and gets shared by somebody who already agreed with me, it's not a waste because it's going to reach their family and their friends and their coworkers that I couldn't reach myself. So that's how I think about things in terms of, which battles are worth fighting for and which ones are not. All right, we're almost done. Lesson number 9. I've been talking a lot about articles, about writing, but of course, reading is not the only way to learn about science. That is something that you should keep in mind if you want to get into science communication. I mentioned YouTube videos before. There are YouTube channels on science. You can do science on TikTok now, apparently. So if the topic that you are interested in requires a visual medium, visual support, then video making might be a good place to go, because then you can have videos and animations, and you can have, and that will really help people understand what you're talking about. And the before times, there were events like science slams that were trying to, again, think outside the box of how to bring science communication to the public in a fun and entertaining way. So if you're a creative person, those kinds of events, and they will hopefully be coming back now that many people are getting vaccinated, that's something to keep in mind. I have a podcast. There are science podcasts out there. I'm not sure how Real Ghost Stories Online is a science podcast, but apparently it is. So if what it is that you're doing is storytelling, a podcast is a good medium for that, because it has this sort of very intimate connection with your audience. But you really have to pick the medium that is best for what it is that you're trying to do. Again, there are things that really require this visual medium where videos or articles with illustrations might be better suited for. Other things where, you want this to be more casual, conversational, or trying to tell a story, a podcast might be a good format for that. So you pick the right format for what it is that you're trying to do. All right, last lesson. I think that we have enough cheerleaders. Now, this is not based on fact or science. This is my opinion, but I think it's an important opinion that I want to share. I see a lot of this online, a lot of, science is awesome and amazing. And if you don't agree with me, then you're denying science. And science is just the most awesome thing ever. And so I see a lot of hype and a lot of tribalism in a way of like, well, if you disagree with me, you're in this other group over there. You're anti-science. We're the pro-science people. I also see a lot of this. A new study shows that journalists love that. You see a new study. Oh, I'm going to write up about this new study. But the thing is that this new study might be a bad study. I'm not sure that eating chocolate regularly will make you skinnier. But if you do a study in a particular way, you might end up with that kind of result. And these new study types of science communication, science journalism, they don't contextualize the study. They don't critically appraise the study. And it can end up with, you can end up with a public who's confused because one day a study shows X, and then the next day a different study shows not X, and then next week a new study shows Y, and it just gets very, very confusing. Not every study is worth communicating to the public about. This is a paper called Toilet Reading Habits in Israeli Adults. I'm glad that these, I'm sure, fine doctors decided to investigate the toilet reading habits of Israeli adults and how it might impact the defecation process in Israel. I'm not sure that this is worth communicating to the public about, right? So just because there's a new study doesn't mean that the public needs to hear about this and needs to have this sort of translated through the lens of science communication. Here's what I would like to see more of in science communication. I do see a lot of it myself, but I'm in this sort of echo chamber of people who are doing this kind of critical science communication. There's misinformation about breast cancer out there. There's homeopathy, as I mentioned. There are bad studies that are done to make it look like GMOs are super toxic and harmful. There's hype around marijuana that apparently cures everything. There are issues with the placebo problem and how it is interpreted by alternative medicine. There's a whole industry of supplements out there that have very little evidence behind them, and these supplements are often contaminated or adulterated. There are scientific things that are very scientific, they're very real, like stem cell therapies, but they are exploited, and they're used to treat all kinds of conditions for which there is no evidence yet. There's the anti-vaccine movement, obviously, as I'm sure you're all aware of during COVID. So all of these things require scientists and science communicators to come in and say, okay, this isn't true, and here's why. And to not look at individual studies, but really to look at the body of evidence on a particular topic to see what the best evidence is that we have on this topic. And the other thing also is to talk about the process of science, right? So how do we do science? It's not just a collection of facts, but it's also a process. And this thing that I'm showing right now, for example, arose because I contacted a journalist who had done a very bad job of doing a report on vitamin C infusions in cancer patients. And as we were sort of going back and forth via email, I realized that she did not understand how drugs were discovered and approved. And so she decided to write about this. And she had this little infographic made to show people like, hey, this is how we study like for new drugs and new interventions, and this is how they end up getting approved. So you start with, in vitro studies in culture flasks, and then you do animal models. And if it still works, you can do phase 1 clinical trial for safety, and then phase 2, phase 3. And if it still holds up, then you apply for your license and you might get approved by Health Canada. And I think that showing this to the public in quotation marks is very useful, because it's not just about this sort of paternalistic of like, hey, today scientists are saying X and tomorrow we're saying Y. No, this is what we're doing behind closed doors. This is what we're doing in our ivory tower. And so it helps to understand this process, because that's what it is. Science is a process. It is not just a bunch of facts. And so I think it is our responsibility as science communicators to explain what this scientist right here is doing in the lab, and the discoveries that she makes, but also the the bad incentives that may be there because she's an academic researcher and she needs to publish or perish, and everything that goes around this and how she goes about trying to get grants and all of that, this entire universe, this entire process. I think to show what is happening in these labs will help the public get a better understanding of how much trust it can put in this or that results. And to remember that ultimately science, all it is really, it's about reducing our uncertainty about the world around us. And our uncertainty will never reach zero. And that's okay. I think that's the main message that I try to convey when I talk about science. We have to be okay with a little bit of uncertainty left at the end of the day, because that's all that science can deliver, right? So there you have it. Thank you so much. Before we go to questions, so if you are on Twitter and you want to find me on Twitter, I am on Twitter. You can just look for my name. I mentioned the podcast that I've been doing for the past 6 years now or so with Christopher Labos. It's called The Body of Evidence. It's a lot of fun. We hope you enjoy it if you want to seek it out. All the articles that I write, I do for the McGill Office for Science and Society. So you can look for that, mcgill.ca/OSS. And all the stuff that I do, including all the media interviews that I do, they're all linked to on my website, which is just myname.com. I will stop sharing my screen now.